right, here is our second example of projectile motion. Again, I'm going to draw a rough sketch. So we have this stunt driver. The problem tells us the road leading up to this cliff is inclined upward at 20 degrees. And this stunt driver is driving at 20 meters per second as they drive off this cliff that is 23 meters tall. We're going to assume the ground below to be level, and it's asking us how far from the base of the cliff does the car land and what is the car's impact speed. So we know this car, as soon as it leaves the cliff, it's going to continue through parabolic motion. And that was really a terrible attempt at drawing a parabola. Okay, the first thing to notice, this is not going to be straight line motion. The car is not going to move in a straight line, which is meaning we need to break our information up and look at everything in terms of X and Y. So not straight line motion means two-dimensional motion. We can still use the kinematic equations because we're still assuming no air resistance, and we of course have the acceleration of gravity, and so the acceleration is constant. When the acceleration is constant, we can use these kinematic equations. But again, when the motion is not straight line motion, we need to look at X and Y individually. So I always draw a rough sketch, make sure I can recognize whether the motion is straight line or not, and then also knowing acceleration is constant. Once we have our sketch, the approach is to fill in our table. So we do need to choose an origin. We can choose that origin to be wherever we want, but I like to put it at the bottom, mostly because then I don't have to worry about having a negative position, though there's nothing wrong with that, of course. So if I put my origin down here at the bottom, I am defining the initial X position to be 0. I know the driver is driving off of the cliff, so the problem tells me this cliff is 23 meters high, so that would be my initial Y position. Finally is going to be down here where the car is going to crash into the ground. Part A is asking us for how far from the base of the cliff the car lands. So that's one of the questions we're looking for, or the answers, I guess. So I'm just going to call the final position for in the X direction just X. The final position for Y, well, we're down at ground level, so 0. V initial. All right, this one, since the car is traveling up this road that's inclined at 20 degrees, this initial velocity has X and Y components. I'm going to draw it a little bigger over here. We're told the car's traveling at 20 meters per second, but the car is traveling in the direction the road was headed in, which was inclined upward at an angle of 20 degrees. So there is an X component of velocity initially, and there's a Y component of velocity initially. Since this X component side is adjacent to the angle, this side will be 20 meters per second times the cosine of that angle. And then Vy initial will be 20 meters per second sine of the angle. So this simply goes back to what we were looking at vectors in general. All vectors can be written in terms of x and y components or magnitude and direction, meaning an angle. When we are using the kinematic equations, we have to have them in terms of their components. And so that's why we're finding those. So this one ends up being 18.79 for and again, I'm keeping a few decimal places simply because we're not at a final answer. You can also leave it as the 20 cosine 20 and 20 sine 20 if you want. All right, what else do we know? Well, V final, I know the x component has to be the same. Because we're ignoring air resistance, we're saying there is no acceleration in the x direction. So that means the x velocity has to be the same as it was initially. Y velocity, we don't know. That's however fast it's traveling right before it hits the ground, and that will be vertically. We do know acceleration is downwards at 9.8. The problem doesn't tell us time, so I think we have the table filled in. So in terms of solving, we do want to know S final. So this x, the x direction, how far the car lands from the base of the cliff, and then what is the car's impact speed? Right that split second before the car hits the ground, it still has that horizontal velocity, but it's now also going to have a vertical velocity. So the problem when it says V, the impact speed, they actually want to know this hypotenuse. So we will need to find Vy final and use Pythagorean theorem to find the hypotenuse that represents the length of that final speed overall. It doesn't actually matter what order we answer these questions in, but let's just start looking at equations. Similar to the last problem, when we want to solve for a final position for x, we can say x final is equal to x initial, which in this case is 0 again. So similar to the last example, the middle kinematic equation for horizontal motion becomes just this x, this final position. I guess I just called it x, so I don't need my f on there. That final distance, that horizontal distance the car has traveled will equal that velocity in the x direction times the amount of time it takes to hit the ground, which we don't know. So we do need to find the time in order to answer part A. Well, last time we had to use the information for the y direction to solve. So let's look at what's going on in the y direction. If we look at the same equation for y, so the middle kinematic equation for y specifically, our origin, we've essentially defined the final y position as y equals 0. We know initial y, we know initial vy, and I forgot my t right here. We know our acceleration. So our only unknown here is t. But now when I put in negative 9.8 and take half of it, I get negative 4.9. So here our only unknown is t, but we have a quadratic equation. And so we need to use the quadratic formula to solve for it, which I don't always remember off the top of my head. Let's see, t will be is it what? Negative b plus or minus the square root of, okay. So square root of b squared minus 4ac all over 2a. So a is the coefficient in front of the t squared term, b and c. So the time will be negative 6.84 plus or minus the square root 6.84 squared minus 4. A is negative 4.9. C is 23. All over 2a. All right, so under the radical, under the square root squared, this part is 22.3066. So I need to add or subtract that, and then I'll divide by this 2 times negative 4.9. So I'm going to get, well, let's go ahead and do it. That $1.578 or 2.974. One of our answers is positive, one is negative. Negative time does not make sense. It implies traveling back in time, which of course we're not doing. So the answer we want is this 2.974 seconds. We can come back now and find the car's impact speed. We know the velocity in the x direction specifically, 18.794. And now we know how long the car is in the air. So let's go with the 2 sig figs. So we'll say 20 is exact, both for this initial speed and angle. 23 is 2 sig figs. So this is going to be 56 meters. This car lands 56 meters from the base of the cliff. Part B, again, it wants to know the speed, how fast the car is traveling right before it hits the ground. So we know it has an x component and a y component of velocity. So part B, the impact speed, v final, can be found by Pythagorean theorem. The x component of the final velocity squared plus the y component squared, square rooted. We already know x, vx final, but we need to find vy final as well. Now that we have time, we could use that top equation, vy final will equal vy initial, plus the acceleration in the y direction times time. So we know vy initial. We know the acceleration in the y direction is downward, so negative 9.8. Multiplying that by the time, we find that vy final negative 22.31. Negative, remember negative means it's headed downwards, which totally makes sense. And it's going quite a bit faster now, which hopefully makes sense as well. Gravity speeds it up on the way down. So the impact speed will be the x component of the velocity at that moment squared plus the y component squared. And then square root of that. Two sig figs, I'll get 29 meters per second. That's how fast overall the car will be traveling right as it's hitting the ground. Now, one other side note, if you do not happen to remember the quadratic formula, that's totally fine, because we could actually find Vy final first by using this third equation and then come back to the top equation to find time. I'll take that approach. I think the next problem is similar in requiring us to find time in a similar manner. So I'll take that approach in the next example. Quadratic formula works great, but if you don't remember it, then it doesn't work great. So just know there's another way to find time in this case.